Yesterday, I taught you about the momentum. What was that momentum? Momentum was given as P is equal to mass into velocity. This was it. Now, in the first day lecture, I told you what is the rate of anything? Anything divided by time is called rate. This is the most important concept of physics, chemistry, and biology, and mathematics also. So anything divided by time is called the rate. So momentum was P. Its symbol is small p. Momentum is equal to the product of mass small m into its velocity. If the velocity of an object is 0, p mass multiplied by 0, then the momentum p will become 0. It means a stable object do not have momentum. Correct? Second thing, if mass is 0, if mass is 0 multiplied by v, again p turns into 0. Momentum is again 0 if there is no mass in the body. Got it? For becoming a momentum 0, there should either not be velocity or not be mass. Got it? Now, I told you anything divided by time is called rate. Here the momentum is going to be divided by time. Means momentum divided by time. Okay. This is called the rate of momentum. But what momentum? If there is rate of change of momentum, rate of change of momentum. What is this rate of change of momentum? Means change of momentum. What does it mean? It means final momentum means momentum final minus momentum initial. This is called the change of momentum. Symbolically, we will represent it by momentum final, P final minus P initial. This is called change of momentum. And when I was teaching you trigonometry, I told final position minus initial position is called delta. This is called as the delta P. Final momentum minus initial momentum. Now I have written here rate of change of momentum. This is the change of momentum rate divided by the time. Now this is called the rate of change of momentum. In the final momentum, we will write P2 minus initial momentum P1, and this is T. P2 minus P1 upon T, or better write delta P upon T. This is delta P upon T. Now friends, what happens? Now you see it carefully that if this is delta P upon T, put the value P2 minus P1. That is P2 final momentum minus initial momentum divided by time. It means momentum rate. Momentum rate. If momentum value of P is equal to m into v velocity, mass cannot be changed. So its final momentum means T2 will become, mass will remain constant, and the velocity is the final velocity small v, and P1 is equal to mass and initial velocity u. I have given a small lecture on the v and u, but therefore this is the time again to recapture that particular day, that the final velocity of a body is represented by small v and the initial body is represented by u. So for the final momentum, mass into velocity, we will use small v, and for initial momentum, mass into velocity, we will use small u. So now the change in velocity, change in momentum, we will put these values. So what these values become? M into V minus M into U divided by time, rate of change of momentum. Now take out M as a constant because mass is not changing. Final value of velocity minus initial value of velocity divided by time. This is called as a momentum P, rate of change of momentum. This is called the rate of change of momentum. Now, Newton said it, rate of change of momentum is called as the force. So, rate of change of momentum is known as force. So, P will become force. F, that is equal to mass, final value of velocity, initial value of velocity divided by time. Means its rate of change of momentum is called as force. This is going to establish a relation between force and mass, and I am going to put this value or solve this value. I will get a new thing. What's that? Let's check it out. What's going to be that? Let's see. Means what I had just written, rate of change of momentum is called as the force. This I am not saying. I am just defining it here and making it simple for you to understand. But what's this? Who told this? This said Newton. So this is known as the Newton's second law. Means rate of change of momentum is called force. This is the Newton's second law. So now I am going to write this final equation over here, and this is F is equal to mass is constant, only final velocity, initial velocity upon time. Now I am going to take time under this value, not under this value. Although we are seeing that this is the value equally applicable for mass and velocity. So you can easily write like this: mass, final velocity minus initial velocity upon time. The rate of change of velocity is known as acceleration. Remember? Yeah, got it. So F is equal to mass, and this is equal to this portion is called the acceleration. So mass into acceleration is called force, or rate of change of momentum is called force. This is the second law of motion. Second law, Newton's second law. Mass into acceleration, and the unit for the mass is kilogram. For the acceleration, meter per second square. So this becomes kg meter second minus 2. This is the unit, or this value in short is also known as Newton. N-E-W-T-O-N. Remember one important thing, that any unit, every unit in the physics is always written with a small letter, like centimeter, gram, kilometer. Okay, whatever this, what you are watching, that every unit is starting with a small letter or a small alphabet. But here, those units which are being named after the name of their discoverer, so they start with the capital letter. So the Newton will be written over here as N, capital EWTON. But the rest of the units are written, suppose Joule. Joule is the name, is a unit of energy, and it is given after the name of the energy discoverer. So the Joule is always Joule. Joule. Why it is so? Because this is an honor. This is an honor we are going to give those discoverers. So the Newton. Sometime a question may arise, or we have seen many times in the competitive examination, what is the difference between Newton and Newton? Question is, what is the difference between Newton and Newton? One is the name of the scientist and other is the unit. This is the difference between these two. If this is written totally in capital letter, then this is the name of the scientist, and otherwise this is. So my friends, what you have seen, rate of change of velocity, rate of change of momentum is called as force. This is the Newton's second law. Force. Now, sometimes what we see, second law of motion, before solving this thing, you can also say rate of change of momentum means delta P upon delta T is called as the force. Rate of change of momentum is called force. And open it. Delta means final momentum minus initial momentum upon final time minus initial time. T2 minus T1 upon T2 minus T1. Final momentum. Again, open it. What this? This is mass into velocity minus dash mass into initial velocity upon T2 minus T1. Take mass, because in both those velocities, initial velocity and final velocity, a body does not change its mass. So if it does not change its mass, it means mass is always constant. Suppose you are moving from your home to your school. Is it possible that your mass changes? No, it's only the velocity which changes. So mass is constant for a particular body. So take mass outside of it as a constant. Now m b minus u upon delta t is called as the rate of change of momentum. And what's this? This is the force. And force is equal to mass into acceleration. This is the Newton's second law. Now, Newton's third law of motion. First, I will remove it out. Hope you are understanding. चलते चलते इसका वो चेंज हो सकता है. One of my internet expert always sits beside me, and if any problem persists, he solves it. That is none other than Mr. Shub, and I think he is the expert in internet connections, movie making, data transfer, and all these steps. So rest of my work he does. I am not that much expert in computer sciences as he is. And he is an interesting guy also. I will tell you about him later on. So this is now the Newton's third law. Newton's third law. I have given a lecture on Newton's first law, law of inertia, Newton's second law, law of force or moment, law of momentum, and Newton's third law now. Now it's NEW, Newton's third law. This is the most familiar law of every student. Every action has equal and opposite reaction. Every action has equal and opposite reaction. Every action has equal and opposite reaction. It doesn't mean if someone slaps on your face, you again start slapping on. Yeah, every action has equal and opposite reaction. Here, if you will, this is a wall. Got it? This is a wall. If you will push this wall by your hands, the wall will also push you. If suppose you are giving a force F, remember this is the first body and this is the second body. See, I am doing it complicated, so you understand its complication. And as soon as you get familiar with this concept of 1 and 2, you will be expert. Suppose this is a ball going to hit this wall. This body is first body and this body is the second body. As soon as this touches the wall, it applies a force F. Force of the first body on the second body. Force of the first body on the second body. This is called as the force. Interestingly, I am going to tell you one important question concept here. I forgot to tell you, but as I have written F12 over here, and that is important part. Remember, what was velocity? Velocity was a vector quantity. Acceleration, as acceleration was rate of change of velocity, so acceleration is again a vector quantity. I am putting an arrow over it. As the force is equal to mass into acceleration, acceleration is a vector quantity, mass is constant, so it becomes a directional, or force can be the vector quantity. So its direction can be seen. So from 1 to 2, this is a direction. So I am putting an arrow on it and I am making it directed. Force on the first body on the second body. And this, as soon as this thing happens, this ball touches, this also makes a force here. That force is called force of the second body on the first body. So, F12 is always equal to F21. Force of the first body on the second body, or force on the second body on the first body. Sometimes in future, when you will come in the class 12, I will teach you force on the first body due to the second body. Force on the second body due to the first body. This is the correct sequence. But this time, I am only saying you the force by the first body on the second body, force by the second body on the first body. They both are equal. But interestingly, it is putting a force here, F12, and it is putting a force here, F21. Its direction is opposite to its direction. So if the directions are opposite, minus sign, I have to put it forward. Their magnitudes are same, so I am putting here equal to, but their directions are opposite, so I am putting here minus. Got it? So F12 is equal to minus F21 means every action he was doing equal and opposite reaction. Equal and opposite reaction. This is the Newton's third law. F12 is equal to minus F21. Every action has equal but opposite reaction. Every action has equal but opposite. Minus test, opposite. F says action. They both are same. Interestingly, F is equal to F12 is equal to F21. Directional, equal and opposite. F21. Every action has equal and opposite reaction. So interesting. Now let's move forward. Hope you got understand. So third thing is, now I was using few of interesting concepts. I'm washing out. And few words I was using when I was last time teaching you physics, a day before yesterday. And that was the gravity, gravitational force, these things. And what is the difference between all these things? Nothing much difference, but one important thing is having a relations among all these three things. What are those? Suppose, what is the gravitation? A word I'm using, gravitation. Gravitation. It's a force. What is this? Gravitation is nothing but it's a force. What's that force? It is a force of attraction between any two bodies. Force of attraction between any two bodies. Any two bodies. B-O-D-I-E-S. But where in the universe? In the universe. And what is the gravity? This is the gravitation. Now gravity. Gravity word we have also seen many times. It is a force of attraction between planet and the body. Gravity, it is also a force of attraction. Attraction. But between any two bodies in the universe, no. Between planet and that body is the gravity. And acceleration due to gravity. Thought is acceleration due to gravity. If one planet is Earth and other is a body, then this is called the acceleration due to gravity. Got it? It is the acceleration in a body due to the force of the gravity of Earth. Acceleration because of Earth. So what is the gravitation? Force of attraction between any two bodies in the universe. Gravitation, everywhere applicable. Means gravitation is a universal property. It's a universal property. Universal property. Everywhere in the universe, everywhere in the cosmos, it is seen. But the gravity and the acceleration due to gravity is only seen. Gravity is a planet in the body. It means the gravity of the moon is 1/9 or 1/10 of the gravity of the Earth, because there is also gravity. But gravity in the Mars, gravity in the Saturn, And the acceleration due to gravity is only in the earth. Means if I am letting it go downward, it means this is the acceleration due to gravity, downward movement. This is also the acceleration, but its velocity decreases, so deceleration. Got it? These are the few words: gravitation, gravity, and acceleration due to gravity. Gravity means one is Earth. Gravitation everywhere in the universe. Acceleration due to gravity, falling a body downwards. Okay, got it? Now, what's the use of this? Newton, which had given us the three laws of motion. Those laws were, we just became familiar of those laws. First law was law of inertia, and the second law was mass into acceleration, means rate of change of momentum is called force. And the third law, every action has equal and opposite. Later on, Newton also gave a law that is called the law of gravitation. What the name was? Law, although law of gravitation. What was this gravitation? Gravitation word, in starting, I told you a force of attraction between any two celestial objects in the universe is called gravitation. If the celestial objects or planets are there between two means one is this and one is this. Its mass is suppose m1, its mass is suppose m2. Force of attraction between these two. But I am standing over here. Interesting fact. I am standing over here, and can I know Aishwarya Rai? No, not possible. Can I know my neighborhood? Yes, absolutely possible. Why it is so? Because the distance between me and she is too much, and distance between me and my neighbor is less. It means the force of attraction will be more when you are close, or the distance between you and that particular body is less. And force of attraction will be more if the distance is more. Got it? So, if the gravitation has to be applied on these two bodies, it means there must be a distance in between these two. But remember all the things and keep it in your mind for lifelong. Whenever distance is measured in physics of a big object, it is measured from its center. Got it? You would have studied about the pendulum. This is a pendulum hanging here from the roof or from anything else. The distance of the thread, length of the thread will be measured from its center, not from the place you tied it, but from its center. This is called its length, actual length. Okay? Why it is so? Because every measurement is done from the center of gravity. That resides the center of a spherical object. So the distance between its center and its center is called as r. Small r. This may change. So mass m1, mass m2, distance small r. According to the positive and the negative charges. According to positive and the negative charges. What's that? Not detecting. Okay. Suppose blood is coming. Is blood again there? Is blood again there? Answer. Target exam. Is blood again there? answer. Anyway, so if this is the force of attraction, this may be force of repulsion also. So this force being acted between these two celestial objects proportional to the product of the masses of both the objects, m1 and m2. Suddenly, everything changed in your life. With this, the concept of IIT started. What's that? Force is directly proportional to the mass product of the masses of two objects. This line is a line for those who are very much intelligent, because they will easily understand. This is a sign of proportionality. Proportionality means either A is proportional to B. We will say this is the sign of proportionality. A is proportional to B. M1 into M2 means the product of the masses of both the object. How you will write it? How you will write it? Now I am rubbing it out and writing within it M1, M2. This is the masses of the body. This is the equation number 1. Equation number 1. Now, relation of force with the R. Force is inversely proportional to the distance between these two objects, R. This is the equation number 2. Now, taking together this equation is totally wrong. Multiplying both this equation is again wrong. If you will multiply this side with this side, got it? What is the relation between these two? Inversely proportional to R square. F is equal to second. Taking both the equations together, we will write it here. Taking both these equations together. Taking both these equations together, we get, comma, we get, what we get? F is proportional to M1, M2 upon R square. Now, this is a sign of proportionality. This is a sign of proportionality. So what happens? I will remove the sign of proportionality from this equation, and when the sign of proportionality moves out, a constant is added over there. So, comma, dot, F is equal to small k. This is the proportionality constant. M1, M2 upon R square. Rest everything is same. F is same, M1, M2 upon R square is same. But the only thing changed is called K. So you will mention here, what is this K? K is equal to constant of proportionality. Constant of proportionality. What is this? The constant of proportionality. Got it? What is its value? Its value is capital G. For this equation, not for everything. Everywhere the value of K changes, so it is a constant. For every equation, this is a changed value or changed magnitude. But for this equation, K is being replaced by capital G. So F is equal to G M1 M2 upon R square. What is this G? This is a constant, gravitational constant. Law of gravitation. So force is the proportional. Force is equal to the proportion, the product of the masses upon distance divided by the distance between two square. Okay. So what is this G? G is called the gravitational constant. G is called not gravitation, gravitational constant. Okay, G is called as the gravitational constant. Okay, friends, the value of the G is changing over here, but important fact. What is that important fact? This is very, very important fact. Everywhere, this is one of the most important fact here. What is this? F is inversely proportional to 1 upon r square. This whole concept, not this concept, this only whole concept is very important. 1 upon r square. Inverse r is unit square. This is called the inverse square law. Inverse square law. This is called inverse square law. So most of the celestial objects follow the inverse square law concept. Most of the celestial objects follow this concept. So you got it? So very important phenomena, the law of gravitation. When there are the two celestial objects or two planets, one planet is having the mass m1, other is having the mass m2. I don't know which type of the mass it is having, and the distance between these two masses is r. So the force they are either is the force of attraction or it is the force of repulsion. If it is a force, then F is called as the proportional to the m1 and m2 and product of the masses of both the objects directly proportional to, and F is inversely proportional to the distance square the distance between these two objects. And taking consideration the both equations together, now F is called proportional to m1 m2 upon r square. Proportions we are removing and putting there the equal to. F is equal to k m1 m2 upon r square. K is known as the proportionality constant. And the value of the proportionality constant for this equation, law of gravitation, is capital G. Capital G is the universal gravitational constant. So F is equal to G m1 m2 upon r square. As this is the force F, therefore the unit of this will become Newton. Newton or simply N. What is this? M1 m2 kilogram square per meter square. Kilogram square per meter square is the Newton. M1 m2 kilogram into kilogram, kilogram square. This is called the kg square upon r square. R is distance is always in meter, so it will become meter square. Kilogram square per meter square. Got it? And the value becomes Newton. F is equal to G m1 m2 upon r square is the gravitational constant value. But now interesting thing. Now a very interesting thing we are going to define you, and that interesting thing is again being shared by some of my colleagues too. And that interesting thing is, if the force is the gravitational force, then what happens? If the force is the gravitational force, then what happens? Then if the force means F is equal to mass into gravity. F is equal to m into g. At this value, what will happen? If one of the planet is Earth and other object is like me or like a car, then what happens? Oh, I have to rub it out. Then what happens? In this law of gravitation, I just told you the formula F is equal to G M1 M2 upon R square. If one body is Earth and other body someone is small body, or one body is any planet and one body is having the mass on the Earth, surface of Earth, then what happens? F is equal to G, a bigger body is M, a smaller body M, upon distance between these two R square. That force is called the gravitational force will be applicable on that small object. So the body will get down by its own weight. That is equal to F is equal to M into G at that time. F is equal to MA, the second law of motion was F is equal to M into A. Acceleration is the gravitational acceleration. F is equal to mg. Now I am putting this value of F is equal to mg over here. So it will become mg is equal to g mm upon r square. The force is being acted on this body. M will cut this m. So g will become g m upon r square. This is the relation. And these two things are over here. So this is the relation between the gravitational force and gravitational constant. This is the gravitational force, and this is the gravitational constant. So what is this? This is a relation between the gravitational force and the gravitational constant. So G is equal to G m upon r square. Now this formula can be rewritten as G is equal to capital G capital M upon r square. Now it is good looking and easy to understand. As a formula, it is easy to understand. Now, what is this? It means what I told you. These are two masses on this surface. This is moving here. This is moving here. This is going to act force on the interesting cheese. Force, ये कहाँ लगाने जा रहा है? Where it is going to apply? Force on the second body due to the first body. Force on the first body due to the second body. This is the first body. This is the second body. And the distance between these two is equal to small r. These are directional. Its mass is m1 because this is the first body, and this is the mass. Its mass is m2. This is the second body. We can define it differently because we have taken small m. So it is very much pretty good for us to apply 1 and 2 over here. But we can say m and small m for this. Now this is capital M, this is small m. We no need to write 1 or 2 here. If we are taking both the small value of alphabet, then we will have to apply, and they are similar. We will write m1 and m2. How simplified form this is here. So I think today you are understanding my lecture very easily. And like this, the gravitational field sometimes we have seen the gravitational field value. Gravitational field value is called a, what is that? I have written over here this F is equal to mg. Now let the value of g be here. F upon m is equal to g. What is this F upon m? What is this called? This is called the gravitational field strength. Why strength? Because the force, your force is called your strength. So this is the strength. As your body has the mass, this is the mass. Force upon mass. This is called these are related with the gravity. So this is gravitational force strength. So this formula will now call G is always a G. But by application of F upon M, it will become gravitational field strength. This is called now gravitational field strength. This is the gravitational field strength. Okay, you got it. Hope today's lecture you all friends or students understood very easily, and this was not a tough one, but very complicated concepts over here in this chapter. I am saying it complicated because what I just taught you is equally I am teaching to those students of mine who are in IIT and MBBS. It is difficult for them to understand this concept sometimes. So whatever I taught you today, take it seriously, and all the best. It is now almost 15 minutes. Have a nice day. Tomorrow I will be here with some other subject, but not physics. Might be many of the messages I am getting for biology, and I am searching if I am having some book of biology or not. What is falling under your course category? Okay. Hope I get few messages which chapter you would like to study. Send it to me in my WhatsApp number, and I will teach you tomorrow. Bye.